go over some best practices for calculating the amount of ingredients needed to make a solution. We'll need our solution recipe and the volume of solution we want to make. In this example, we'll be making TAE, a solution commonly used in molecular biology labs, and we want to make 5 liters of it, enough for us and our lab mates. Solution recipes are written in terms of concentrations. We use concentrations because they're always the same, regardless of whether we want to make 50 milliliters, or 5 liters, or 50 bazillion gigaliters of the solution. We typically measure concentrations in units of molarity, aka the number of moles of solute per liter of solvent. Note that in TAE, the ingredient concentrations are in units of millimolars, but don't sweat it. 1 millimolar is just 1,000th of 1 molar. First, note that tris is usually stored as a solid, while acetic acid and EDTA are usually stored as concentrated liquid solutions, known as stock solutions. There are slightly different approaches when working with solid or liquid ingredients. Let's start with the solid solute tris. Our solvent is water, which is the most commonly used solvent. To figure out how much tris we'll need to make 5 liters of TAE, let's write out our 40 millimolar concentration in terms of millimoles per liter. Our goal is to convert this to an actual amount of tris we can add to our water. First, let's convert millimoles to moles. To do this, we need a conversion factor relating the two. A millimole is 1,000th of a mole, so we can create our conversion factor by dividing both sides of this expression by 1 mole. Remember that whenever we divide a unit by itself, we can cancel out the unit. Now we have a conversion factor that relates millimoles to moles. Because the conversion factor equals 1, multiplying it does not change the value, only the units. Next, we can use this conversion factor to convert the tris units into moles per liter. Be careful to arrange your conversion factor so that units cancel out. We're now ready to determine how many moles of tris we need for our solution by multiplying the concentration by the final volume. We're making 5 liters of TAE, so we'll multiply by 5 liters. Turns out we need 0.2 moles of tris. But how do we know how many grams this is? We need the molar mass, aka the molecular weight, of tris. This is the mass of tris that contains 1 mole of tris molecules. The molar mass of a substance can be found on the label of the container it comes in, or you can look it up online. Tris has a molar mass of 121.1 grams per mole, so we can just multiply that by the number of moles we need. The moles will cancel out, and we're left with the number of grams of tris we need. 24.2 grams of tris to make 5 liters of TAE buffer. Now it's time to figure out how much of our liquid ingredients to add. Since we're taking concentrated liquids and diluting them to get our desired final concentration in our TAE, we can use a really handy formula that goes like this. The concentration of our initial solution, multiplied by its volume, is equal to the concentration of our final solution multiplied by its volume. Let's use this equation to figure out how much acetic acid we need to add. Our TAE recipe calls for 0.02 molar acetic acid, so we'll go ahead and pop that in for our CF value, and we want 5 liters of it, so that will be our final volume value. Next, we need to write in a value for CI, the initial concentration of the concentrated acetic acid stock solution we have in the lab. A common form of concentrated acetic acid is glacial acetic acid, which is 100% acetic acid and 17.4 molar. We can write this value in as our CI. Now we can solve for the initial volume to find out how much glacial acetic acid we should add to our solution to reach our desired concentration. Remember to keep track of your units so that you know what unit the final answer is in. Whenever we divide a unit by itself, we can cancel them out. It turns out we'll need 5.7 milliliters of glacial acetic acid for 5 liters of TAE, which we can include in our recipe. EDTA can be found in the lab either as a solid or as a concentrated stock solution. Let's figure out how much EDTA to add, assuming we have a 0.5 molar EDTA pH 8 stock solution available. We'll return to our favorite CI-VI equals CF-VF equation. Assuming we have a 0.5 molar EDTA stock solution, that means our CI is 0.5 molar. And we know our CF is 0.001 molar, and our VF is 5 liters. Plugging those values in, we find that we need 10 milliliters of EDTA. Hooray! We've figured out how much of each ingredient we need to make 5 liters of TAE.